So now, today I'm going to talk about server-side rendering in single-page apps. And I guess Meteor is in this talk just really an example of a single-page app. It's something that I've been looking at a little bit recently, and I think there's a couple of subtleties involved that that maybe people aren't aware of. So I think it's a pretty interesting topic. And so we'll look at a couple of Meteor sites as examples of apps that could be improved with some server-side rendering. So let's start with some definitions. So what's server-side rendering mean? It means that when you hit a URL for the app, you get HTML that's relevant to that URL. The server is producing the HTML that you need. This HTML combined with the CSS is enough to draw something that you need to see. And traditionally, the rendering is done only on the server, usually using a different technology. So what you might use is basically not JavaScript. So if you do anything client-side on a server-rendered app, it's usually very different to what you do on the server. And so this is Wikipedia. This is sort of stuff that the server will send back to you when you go to Wikipedia behind the scenes. So this is the complete page. There's a lot of stuff there. What's a single-page app? So a single-page app is it's a bit of a vague term, but it tends to mean an app that is rendered on the client in the browser, and therefore using JavaScript. Traditionally, and in Meteor in particular, doesn't matter what URL you hit, you'll always get the same single page of HTML. Doesn't matter what URL you request, it basically just dumps you the exact same thing, which is just enough to bootstrap the JavaScript, which will then kick off rendering. So we'll have a closer look at that in a second. So this is what Verso, as an example of a Meteor app, serves. Doesn't matter what URL you go to, in this case it's the root URL. But you can see there's really not a lot here. And we can take a little bit of a closer look at what's here if you've never looked at it before. So at the top, you can see the CSS, which is what we need eventually to render things in the right way. And that'll download before it tries to do any rendering. There's this big splodge of config that the app will use. And then this is the all-important JavaScript file. You can see it's served from a CDN, but this is a big file. It's like in the order of a megabyte. And the user needs to download that file before they'll see anything. There's not even like a loading screen here. There's nothing in the HTML. The user will not see anything until this big JavaScript file has downloaded. So let's have a closer look at what actually happens on that first render when you hit a page in Meteor. So I've sort of broken it up into 3 steps or 4 steps, depending on how you look at it. 3 things that happen that join these steps. So first you type the URL into your browser. Eventually the server comes back and gives you some HTML with some links in it. And your browser then goes off and requests those links. In this case, the important thing being JavaScript. Then the JavaScript comes back and it runs. And in Meteor's case, it then goes and fetches all the data that it needs to render the app. And it uses DDP to do that, which is a WebSocket protocol that Meteor uses for all of its client-server communication.
DDP is pretty cool.
Then eventually that data will come back over the wire, your app is ready, and it will render. And we can talk a little bit about how long these things take, because you may be used to Meteor apps taking a while and not really break it down into these steps. You might just think it's all about how long the data takes, but I mean, depending on the context, it can make a big difference. So depending on where your server is hosted, the time it takes to make the round trips required to get even that most minimal HTML that we saw on the previous slide can take a while, depending on the latency to the server. Usually it takes at least 2 round trips to establish the connection properly and to establish the HTTP connection and get the actual HTML. The server probably in Meteor's case doesn't take long, but even so, if it's like, for instance, the server's in California, like in Verso's case, and you're in Melbourne, that can take quite a while. How long does it take to get the JavaScript? Well, you'd think it's a big file, it could take quite a while, but then again we're using a CDN, it's probably pretty fast. And you might also think, well, this is only relevant to the very first time the user accesses the site. We aggressively cache the JavaScript. From then on, it'll be fast. I guess I would respond to that with a couple of things to think about. One is, every time you do a hot code push, you've got a new JavaScript file that has to be completely cached in its entirety. And secondly, on a mobile browser, even if the JavaScript file is cached, and it may not be, it still takes the browser quite a while to even interpret that file, if it's a really big file. So this step 1 to 2, even past the first load, can still take some time. And then 2 to 3 is very dependent on how much data you actually need to render your page, obviously. But DDP is a little bit of a heavy protocol. It does have quite a few back and forth to get the connection established, work out the protocol. It's not, well, I shouldn't say it's a heavy protocol, it's not, but there's a few steps required on top of the WebSocket steps to get the connection established. So all of these steps can, in some circumstances, and usually take some amount of time and are worth thinking about. So let's see what this actually means for a media app. So here's our example media app with Verso again. So when you type in app.versoapp.com and hit enter in your browser, what happens? So the first thing is we go from step 0 to step 1 and we get our HTML. The HTML is now loaded, but we still don't see anything because it's essentially an empty HTML tag. So now the browser is off, has the HTML, it's getting the JavaScript, but we still can't see anything. We're still looking at a white page. The JavaScript's getting fetched. Now the browser has the JavaScript. What happens next? It renders a loading page. So we see a spinner, and it's now fetching the data. Once it's got the data, the app is ready, and we can see our beautiful dashboard. Sorry about my test data. I could probably have picked a better account to do that for me. So how can we do better in Meteor than that? In vanilla Meteor, we can't really do anything about the technical limitations of what's going on. So, but one thing we can do, and this is something that you'll see in more and more sites, particularly Facebook does this, you may have noticed, is we can anticipate the data that the user is going to see and make it appear like it's ready before it's actually ready. And we call this in-page loading. So a site that we do this on is Atmosphere, and you probably notice this when the loading takes a long time. So the process here is the same. We fetch the HTML. We still need to wait for the JavaScript before we see anything. But now we render a loading page which looks a lot more like the real page. So if you've used Atmosphere at all, you'll notice that you'll remember these things pulse. You're actually scrolled up. I've just scrolled down to make it obvious what's happening. And if it's fast enough, you might not even notice that there's a loading stage where those empty squares get replaced with real data. That's a bit better. But can we do better than that? Well, let's think about the traditional old school style of rendering everything on the server. How does it look there in this way of breaking things down? Well, we still, and this is my example here I use is percolatestudio.com, which don't go and look at now because it doesn't work like this right now, but we're about to deploy a new version that will work like this. But you can replace that with any old school site, Wikipedia, for instance. So the first thing you do is fetch the HTML, and then once that's arrived, boom, you can see the site. Now in the background it's fetching JavaScript, it's potentially fetching data, but nothing's changing. You can already see it. So all this stuff is happening, but the user doesn't really care. So it's a lot better. But the downside is, of course, what I said at the start, which is a server-rendered app usually use different technology and you get all the niceness of single-page apps where the client is controlling the browser. But can we do better? Can we combine the two? Well, we can now. Technologies such as React, I talked about a couple of months ago, and soon Ember, and hopefully one day Meteor, will render in Node on the server. So the HTML is rendered in exactly the same way by the same framework on the server. Then the JavaScript, once it's ready, once we reach step 2 of our process, can take over the HTML of the page, and the user won't even notice. So this seems like the best possible approach. It's great. We've got the best of both worlds. There are a few problems that are worth thinking about. I call them uncanny valleys to refer to the almost perfect but not quite weirdnesses that you might notice. So the first one is the unresponsive page. So at point 1 in my flow, we've got the HTML, we can see the page, but we don't yet have the JavaScript. So what happens when you click on something? while your app's still waiting for the JavaScript. You might think, oh, that's silly, but it does happen on the phone. What happens? The app appears to be really unresponsive. So here at step 1, we can see the page, the browser's off getting the JavaScript, but what happens if I start clicking this link? This is as it turns out, this contact link opens like a dynamically rendered form that is whacked on top of the page. If you happen to click that link before the JavaScript is ready, just nothing happens. It feels like it's broken. So what can we do about it? Well, there are a couple of things. One, we can indicate things aren't clickable. So we can make that link look, when we server render it, we can make the link look unclickable, and then when we client render over the top, we can make it look clickable again. This is kind of what, sort of, I see kind of equivalent to what iOS does, where when you open an app, again, it will show you the last screen, but like you can't use it. So it's kind of, there's some analogies there. The second thing you can do is use real links with real hrefs. So if you saw the other links at the top of my picture earlier, they were real links. And if you clicked on them, it would bootstrap the whole loading process again at a different URL, which isn't the perfect in-page, single-page app experience of a transition and all that, but at least it works. So it's a real argument to either use links and take advantage of that, or don't use links if you don't want that to happen, because it will. Because there will be no JavaScript cancelling, preventing default on that click on the link. So what about at the next step, step 2? So at point 2, the JavaScript is loaded. So this is the second last step of my process. The JavaScript is loaded, but it doesn't have any data. So how can we re-render the page over the top if we don't have the data that was used to render it? So imagine that we did this naively. This is what would happen with Verso if it was served by the server. We'd render the first page, we'd request to the server would render the HTML. At this point we can see the page. Great, awesome. Now the JavaScript's loaded, but it doesn't yet have any data. So now if at this point 2, we tried to render, we'd go back to the loading screen while we waited for the data. And then we'd get back there. Obviously we don't want that to happen. What was the point in server rendering with that? So what can we do? Well, we can just not render at point 2 and wait to point 3 to render the JavaScript, but that just extends that time period of our uncanny valley 1, which is the unresponsive page. So that's one solution. It's not the best. What is a better solution? Well, they call it hydration. And basically the idea is that when the server renders the HTML that the user needs to see, it also, embedded in that HTML, ships the data that it used to generate it. So that when the JavaScript is ready, it already has the data that it needs to render the page. And this is called dehydration, dehydrating the data and then hydrating it again on the client. And actually, in Meteor, you can do this. Fast Render does it. So if you guys have heard of Fast Render, this is exactly what Fast Render does. And we can take a closer look at what this actually means. This is React, but you'll see something similar with Fast Render. But in this case, it's React. We've got some server-rendered HTML at the top. And then if you look closely here, you'll see some JSON kind of stored here in a script tag. The application store is storing some stuff. The time store is storing some stuff. This is all the data that the React app needs to render. So this is the hydrated data. So that's great, but then we have one final problem that happens as a result of that, which is getting very technical. But what happens if my JavaScript now renders with the dehydrated data and I start clicking on things? I start trying to change things. I click a like button. How can the JavaScript modify that data when it hasn't yet, and if we think back to Meteor, established the subscriptions to supply that data? What if it tries to modify that data, but then later the real data comes back over the subscription? Will it undo my modifications? And the answer is yes. And for instance, this is a problem with Fast Render. It doesn't deal with this issue. So there are edge cases where if a user clicks too quickly, does certain things too quickly, in Fast Render you'll have problems. Again, the solutions are don't let the user click until you're ready for them to click. That's one solution. A better solution would be for the framework to handle it for you. And it's actually, if you think about it, very similar to latency compensation, or I call it automatic latency compensation, which is, in my opinion, one of the best features of Meteor, probably the best feature of Meteor. which is in Meteor, when you make a modification on the client, it will compensate. It will do it instantly on the client, optimistically, and then when the server comes back, it will throw the client's change away and replace it with the server's. And that's the idea of that is latency compensation, and other frameworks are now catching up. So React has this idea, they call them optimistic updates, which are a similar, it's the same idea of latency compensation, but the difference is, in React, you have to wire it all up yourself. So you have to say, when the user clicks this button, do this. But then if the server comes back and says it worked, then do this. But if the server comes back and says it didn't work, then undo it. You have to wire that all up manually. In Meteor, that all happens completely automatically. You don't even think about it. You don't even realize it's happening a lot of the time. That's why I call it automatic latency compensation. And actually, if you think about it, it's the same thing as how do I modify this hydrated data that's static while I'm waiting for my subscriptions to be ready? Well, I just need to be able to modify them and to know that the real modifications are going to happen on the server, and that the server will tell me when everything's all good and I can throw away those modifications. It's very similar to the latency compensation problem. And I look forward to the time when MDG builds that into the framework, and then Meteor is going to kick ass at server-side rendering. So that's it. Okay. Yeah, questions? Yeah.
I mean, hydration seems to be just same as bootstrapping data, but when we used to do with Django, we have an Ajax app.
Right.
Send a JSON log along.
Right.
I get. Or is it? Yeah, it's sort of.
No, it's more or less the same idea. I guess the key difference in Meteor, though, as opposed to something like Django, is that in Django you're kind of in control of when you go and fetch more data from the server. So there's really no problem with doing it. There's no like worries about doing that, right? It's just avoiding that first. See, in a RESTful app, you would make a request, right? Like if you didn't bootstrap, you'd make a request for the initial data, right? And then you'd have the initial data and you'd run from that. And having it there sitting already in the HTML is great. You don't need to make that first request. But the problem is in Meteor, like the server pushes data to you. You don't request for it, right? So in Django, you'd make that initial request, and sometime later, maybe you'd poll for more data, or when the user did something, you'd go and request more data, right?
Yeah.
And so you'd be prepared. You'd be like, cool, I'm going to replace my hydrated data with the next set of data. That's fine.
Sure.
But in Meteor, the server's going to be pushing data at you, and you don't know what data the server's pushing at you is already in your hydrated set or isn't. So you kind of have to, and subscriptions become ready at a certain point, and it's all a lot more complicated. And that's the price you pay for like real time.
Yeah, so the next question was going to be like, it sounds like there's another layer of complexity with latency compensation. Previously, latency compensation assumed that your subscription's already warmed up.
Exactly. Yeah.
And you're just respecting an action client side. But let's say like this time your subscriptions are not warmed up, you're expecting an action client side, and then negotiating.
Yeah, exactly. Which is why I think like Aaron Oda was right to not try and solve that problem with fast render and just kind of, I think, just ducks it. Just says, oh well, like there are certain cases where things can go wrong. I think the framework needs to have support for this in it. Basically it needs to have support. Live data needs to have support for like a hydrated mode. Or a bootstrapped mode, or whatever the terminology is.
Even if that's the case, like, do you think like it's worth it? Like fast render, what they experience of something is seemingly load fast, but the user base is probably used to like a little loading message sometimes.
I think it depends on the app, right? Like if you've got an app where it's very unlikely that the user's going to do anything in the first 2 seconds, right? Like say it's a blog. Then I think, yes, it's definitely worth it, right? But if you've got an app where a user might hit a like button or like, do something very quickly, then I think you might want to be a little bit more careful. I think it's, like many things, it's like, it depends.
I think part of it is also being indexable by search engines, because a lot of them don't have JavaScript. Yeah. So if you're pushing out the HTML in the first go with all the information that is rendered, then they can just kind of scrape through that rather than index your site.
I think living here in Australia, we have the problem way more than people living in America, which is that sites do take a while to load, even to see anything. And So server-side rendering isn't just about SEO. I didn't even mention SEO, but it's definitely a factor. We don't know how Google works. They claim to run JavaScript.
Yeah, partially.
I don't know if we believe them. Cool.